All right, so hi everyone. So welcome to this long overdue consortium call. So I guess we can start with some brief news, and then we can, move on to the analysis presentation. Does anyone want to report anything? So I can give you a couple of brief updates. So first of all, I think today finally I sent the consortium agreement to be signed by uh, um, the president of Earth. So once I get the signed copy, I will forward it to you so that everyone can copy. Sorry, because there is some noise by my daughter. So let me just try to close the door. Okay, sorry. So yeah, so once I have the signed copy, then I will forward it to you so that we can get this over with. The other thing is that let me try to share my screen. Can you see my screen? So we have a new website.
Yep.
Oops. Sorry. Too many. Okay. So this is how it looks like. It's online, so at this address here, so argos/telescope.eu. The thing is that it's still the content still needs some work. So there are several things missing. I'm just trying to copy over things from the old website, but I still need some time to finish this. But yeah, it's it's also done. So we're doing some tests now, internal tests, but once it's in a mature enough state, then I will probably contact some of you to give you accounts and access to the content and so on and so forth. And oh yeah, and also we have a project manager who is going to start this Thursday. So on the next meeting, she will hopefully be able to join. So I think that was all from my side. Anything else? Anyone else who would like to share? Okay, so if
nothing.
not,
I still owe you, Yanis, the data management plan. I hope to be able to finalize it in the next 10 days.
That's good. Yeah. Okay, thanks. Thanks, George.
Plus that we have also filled in the open position for the postdoctoral researcher, and the plan is to open another one that will be more oriented to software engineering, because this one will be mostly tailored to the machine learning and signal processing part.
Fantastic. Yeah, looking forward to meeting the new people. Okay, Thanasi, would you like to share your screen?
I'm not allowed to.
You're not allowed to. Try now.
Okay. Good. Can you see it?
Yes. Okay. So the background is that we're planning to do a first RFI measurement campaign at Skinakas, where the Pathfinder will most likely be installed. And so Thanas is going to present some of the plans of his team for this campaign.
Actually, Yanni, this protocol is generic, so it may be repeated wherever we have to.
Correct. Yep.
So I will start with the square kilometer array memo 37, on which the criteria for the RFI evaluation will be based. And this memo is also based on the ITUR recommendation RA 769, which actually outlines all the RFI levels that may be harmful to radio astronomy. And all the frequencies that are within this recommendation are also given by the CRAF handbook for radio astronomy. Now, why we will use the memo 37 as a basis? Since the ITU recommendation would require months of continuous observation, the square kilometer array memo defines a different protocol for these measurements, which can be performed within few weeks. So this protocol seeks to identify all the signals or the RFI signals originating from terrestrial or airborne sources, and all the signals from satellites or other astrophysical sources are not included in this protocol. Nevertheless, as you will see, we have taken into account that we will have two new positions, so the antenna will look also at the sky in order to receive these signals from, at least from satellites, either geostationary or non-geostationary satellites. And it is sufficient, this protocol, for the selection of sites for the installation of our telescope, our radio telescope. So there are two modes of measurements that are defined in memo 37. Mode 1 measurements are for strong, very strong RFI signals that could impact the linearity of the receivers, and mode 2 measurements seeking for really weak RFI signals, which may threaten to obscure weak signals of interest, of our interest. So the two modes have completely different specifications regarding the partition of the frequency bands, the sensitivity of the equipment, the resolution bandwidth used with the spectrum analyzer, the dual time, which is the integration time within the resolution bandwidth to measure the power, and also the total measurement time. Let's see some basic technical specs that are given by the memo. For mode 1 measurements, the receiver temperature should be less than 30,000 kelvins. And for mode 2, this is a strict spec here. The receiver temperature should be less than 300 K. The antenna height should be at 5 meters, plus or minus 1 meter. We should examine both polarizations, vertical and horizontal. We should cover the entire azimuth 360, and directional antennas should be used for this coverage. The frequency range set for the square kilometer arrays from 70 megahertz to 22 gigahertz, but for ARGOS, the nominal range is from 1 giga to 3 giga. But as you will see, we will examine frequencies from 900 megahertz to up to 3 gigahertz. in our measurements. And also in the memo, the calibration is given and is required. And it said that we have to measure the gain and also the noise figure, the noise temperature from the antenna terminals back to the receiver in the field at least once every 24 hours of measurements. So the mode 1 measurement cycle has specific settings, as you can see in this table. We have two bands, two sub bands, we can call them, 960 to 1.5 giga and 1.4 to 3 giga. And the total time needed, as the memo said, is 1,400 seconds. In this table, the figure S08 is the expected flux density at the horizon level for a signal that is matched in bandwidth, and a signal that is a strong one, minus 100 dBm at the antenna terminals. Also in this table, you can see the dual time, which I repeat, it is the length of time that the channel is examined, is measured. So it's equal to the integration time in the resolution bandwidth that we use for the measurements, the IF filter that we use for the measurements with the spectrum analyzer. You can use this this equation here to measure the sensitivity of the equipment. And also in the memo, it is said that we need 5 complete sessions, which means that we have to measure 5 cycles as the cycle is defined in this table. So we have 5 cycles per point in direction, per polarization. So if we have 5 different pointing directions in azimuth, we get 10 cycles per directions and totally 50 cycles in total. So this means approximately 20 hours of measurements, which is not the case as you will see later on. We need many more hours of measurements. And to this duration, we have to add the time to set the spectrum analyzer, to save the files, and rotate the antenna and all this stuff. So we will need approximately 90% overhead. In mode 2 measurements, we have a similar table. The partition of the frequencies is completely different, and also the way you measure is completely different from mode 2. For the ARGOS RFI measurements, we will focus to mode 1 measurements and mode 1 specs. So the sensitivity of the equipment that we have available this time in our lab is excellent and applicable even to mode 2 measurements. So we would like, and we will do that, we will have a measurement chain, an RF chain with a noise figure very low. So the noise temperature will be less than 300 K, even for mode 1. And the protocol that we will use will include also, as I said, a setup for signals from satellites and other sky sources. So what we will need at Skinakas, at least at Skinakas, availability of power supply. So we'll need regulated power supply, 220 volts. We will need a tower mast, at least for 4.5 meters. And some persons from Forth that there are already available. And the campaign will take place during week 27, which is 3 to 8 July, in approximately 1 month. So a short measurement will take place initially at Forth premises, just to check that everything works fine, and we will check also the way we will put the measurement equipment on the mast that will be provided by Forth in Heraklion, and then we will have a full measurement at Skinakas. This is the schedule. The measurement equipment that will be used is shown here. The block diagram is shown here. We have the antenna, LNA. We have actually two LNAs. For every component, we have a backup since the whole campaign is really difficult and we don't want to face any problem during the campaign. So we'll have two LNAs, one with 35 dB gain and one with 40 dB gain. They do have a low noise figure. Then we'll have a 10-meter cable, then a bandpass filter, and then we'll have the spectrum analyzer, which will be controlled by our laptops. An alternative chain is shown in this figure, where we might need an attenuator for the measurements at Forth. In Heraklion, we may have very strong signals, and in order to protect the signal analyzer that we use, we may need an attenuator. So we may add this attenuator for the initial measurements at Forth. In this slide, which is available also in the Argos Cloud, I have uploaded all the presentation in Argos Cloud. You can see that after this meeting. You can see all the parameters that are needed for the setup of the measurement equipment. And let me explain you a few things about the two bands. For the first band, which is from 900 megahertz to 1.4 giga, we will need approximately 28 hours of measurements. This is clear measurement times. So I have included here 5 positions in azimuth for the vertical and the horizontal. So 5 plus 5 plus 2 for the 2 positions for the sky measurements. And these have to be repeated for 5 times. So the sessions are 5. So the total duration is 20 hours, as you can see. Whereas for band 2, we need approximately 9 hours of continuous measurements. So I have included this table here. We will have at least 1 session at Forth, and the total time needed is 7.4 hours, as you can see. But to this duration, you have to add all the time that you need for the preparation and also for the calibration of the measurement equipment. Whereas at Skinakas, we will have a full 5 sessions measurement. So we will follow the memo as we should do, and we will have 37 hours of clear measurements. As you can see, it's really a difficult task, and it will take us approximately 5 to 6 days. So we will go to Heraklion early morning on Monday. We will arrive by ship there. We will bring the equipment, the measurement equipment, and we will leave Saturday evening. So we will have 5 or 5.5 days available for the whole measurement campaign. That's it from my side. We can discuss if you want any questions you may have.
Thank you, Thanasis. Are there any questions? I do have some questions, but let's see if anyone else wants to speak first.
Can I ask? Will you do your measurements in the plateau? Yanni, you probably know better. In the plateau below the small observatory, at the peak? I mean, how?
No, so ideally we want the equipment to be placed where Argos Pathfinder will be deployed. So that would be the plateau behind the solar panels. No.
Okay, to see how we can have electricity power there.
Yes.
Because
If I can interrupt
electricity-
here, first of all, the trailer can go in a place that is possibly a trailer to go. So I remember, Yanni, the plateau. You mean the one that we took the measurements there, inside the rocks and all these bushes? This is the
Yeah,
place
but there
to have
is.
in mind there.
Yeah, but there will be so there is as you know, there is some construction going on now in the mountains. So the idea is to have some path opened by the time we go there with a trailer, so that we
Okay.
can,
I mean, this is
if
important.
yeah, of course. But if that doesn't happen, of course, then we'll have to find a place that's go as close to that place as possible.
Okay. And this is the first. The second one is related to the power. We will have power. We have three different resources in the trailer. We have, the batteries. Then when they are fully charged, the batteries, then it's fine. Then we have the solar and the wind turbine be in the position, to charge the batteries. And if not the case, for any reason, I don't know why, maybe not, we have an electric generator. So this will be, the last option. If you think that is interference from the generator, this is why
There will be for sure. So
yeah. Anyway, we have the batteries that at least equipment that are in the trailer. I think that it's only from us. I mean that the inventor. I don't think that may produce any. Exposure. However, I think that will be okay. Otherwise, if not for any strange reason, we can take a cable and charge from the from the house close to the solar area in the Skinnacas. But I think that will be fine. Done in the past.
Let me ask.
So you will not. Sorry. You will not take power from the batteries of Skinnacas, from the solar panels.
No, only if needed. I mean that it depends on how many hours and if you to avoid any potential risk of stop a measurement or I don't know for any reason. But in general, especially if it is during the day, will be okay. But just let's consider second plans if something wrong, so or whatever. Yes, we have as the last option the cable coming from the Skinnacas. So. I think that will be okay, but okay, we have second or third plan, so I think that will be fine on this. Otherwise, we can, especially we have also the electric generator that if you place it away, if you think that, Yanis, that there will be any issue, I don't know how many meters you think that there will be any interference, but then which frequency you mean, anyway.
Sorry, Merlin, that's the question. We need to be regulated. I mean, the voltage should be regulated. So either from the trailer or the main supply from the solar panels should be regulated. Is that correct? Is that regulated?
It's from inventor that is specific. The output is specific. I mean that 230. It's regulated. I mean that. It's a central point of of power. So all the charging, the batteries are going from there. So you take power from there, always from there. All the other are points for for charging, I think like that. But the inventor is the final. It's a good inventor.
Mary?
I have a brief follow-up question regarding the solar panels. Are them connected to a battery so to provide power all day long, or you have the energy supply only during the day with the solar panels?
No, there are batteries and there is electricity 24 hours. Only in the case that there are clouds or we need something with a high consumption like a crane or something with a high watt consumption, then we open the generators. If we have a cloud for many days, maybe we need to recharge the batteries with the generators because we also have generators, of course.
Is there any study or report regarding the solar incidents at Skinacas or like the battery solar panel system? Is there something where
Written, you
could
mean
learn-
a description?
yeah, like what it's installed there, how it's working, the study of the amount of sunlight available there?
Not officially, not this kind of statistics. The technical I can provide, but not statistics.
They are quite old, though. I mean,
No, the batteries are new. The batteries are new. The panels are old, but the batteries are new.
No, because I was thinking it just more from the point of view of calculating, providing a
Yes,
number
I
of
can-
antennas
I
of
can,
black, how much, whether.
I can ask my
Okay.
colleagues and I'll let you know about how often we need to put a generator to charge the batteries and what is the consumption we have as a standard, and I'll let you know because I don't know these
Thank
numbers.
you, Anna.
Thank you.
Okay, sorry, I must leave because I have a meeting with my student now. Sorry.
bye, Mary. Okay, so I have a couple of questions. So one question, Thanas, is regarding the calibration. Can you
We use the noise source for the calibration.
Okay,
we
so
use the noise
where in the signal chain
we
that
will
you
remove the
showed?
antenna at the front. We will remove the antenna, and there we should put the noise source.
Okay,
So it's from the antenna back.
okay.
So
And
you
that
have
will
all the LNAs, the cables, the filters, everything.
yeah, okay, okay. So the other question is regarding the protocol. So I think if you can show your slide 6 again.
Yep, just
Where you show the there's this table with mode 1 cycle.
just a moment. Yep. This one.
Yeah.
Yeah.
So I was a bit surprised that you know the dwell time, the integration time is so different between these two bands. Any idea why?
Yeah.
Why is this? Do they?
It goes in this in the first band from 960 to 1.4. There are many radar signals there. So if you have radar signals, the length of the pulse may be up to 2 microseconds.
I see. Okay.
So you have to be able to measure this one, and then it stops. I mean, if you have radar, you may receive just a small pulse with 2 microseconds duration, and then it will come again maybe in 2 seconds, in 10 seconds, in 20 seconds. It depends on the way the radar works. So you need this one, and since you stay a very short time in the resolution bandwidth in this filter, you have so many repetitions. You have 1 million repetitions. So you measure the same thing 1 million times in order to catch the small pulse.
And how much of that band can you record simultaneously with your equipment? I mean, how much of the 961?
It's a spectrum analyzer where you sweep. It's a sweep mode.
Okay. I see.
So you have, for the first band, you have the one megahertz resolution bandwidth, and you sweep it. Okay.
Okay.
And Thanasis, regarding the band, 1.4, to 3 gigahertz.
Yes.
Do you consider taking measurements for all this band, or split it in shorter?
We will split it in 30 mega spans. So we will have 54 54 spans of 30 megahertz each.
Okay.
Yeah, that's correct. So we will go actually from 1.4 to 302, 3020. I mean, 20 megahertz above the 3 giga. We will have 54 spans of 30 megahertz each.
And regarding other bands, I mean that, okay, I totally understand, or I don't know, that what we are expecting from the space, I mean, that from the sky. But there are some other interference from coming from TV bands or radio, or, that may...
These are out of our band.
Is it? This is an astronomical question. I don't know. Do they have any...
ARGOS is from 1 giga to 3 giga. And we're going to measure from 900 mega to 3 giga.
So we don't care for other frequencies. This is the question.
No, I mean the only worry there is if there's something really strong just outside of these bands, and
already we will have the 960 mega.
Yeah, but I think the strongest possible signals are in this 962
and 1.8 giga.
Yeah. So
this happens in the cities. I mean, up to Skinagas, I'm not sure if we will have really strong signals there.
You will have.
Really?
Mm. The measurements I took there, I saw completely difference when I was in the plateau, down. But when I was up, I could see Heraklion, I could see everything. And when I took the spectrum analyzer with the directional antenna, I can see a lot of signals around, because it's a total, line of sight with a lot of spots there. And imagine when we have the mast up to 9 meters, then the mast should see a lot of things. So this is my consideration, I mean, that regarding this. Anyway, I think that this is the main point of this campaign there, to see this kind of things.
Yeah, and we have already started also the all the procedure. We have set up all the procedure of the offline processing of the data. So we want to come up to Skinakas with the whole procedure finished. So we want to have a first idea of what's going on up to Skinakas when we are still in Skinakas.
excellent. Yeah. So on that note, I think it might be useful. I mean, one thing I was hoping to do before you guys come is to go up to the mountain with our equipment, so a smaller like antenna and spectrum analyzer, just to get an idea of mostly the self-generated RFI. So things like the inverters or the generators or the equipment that is running the telescope. I just want to get an
generator working on. I mean, no generator should be on.
Yes, sure, but there are other things that we might not be able to close. So I mean, I just want to see the data.
Helpful, yeah. And also check that we will have the power supply.
Yes.
Can I ask from a practical point of view? One is that the generator should be off. Second, Wi-Fi will be off.
Yeah, for sure.
What other things should be?
Mobile phones.
Mobile phones.
Cell phones.
Any transmission. No transmission.
And tourism should be off as well. There are a lot of tourists.
Yeah, we should take care of it. Okay. What else?
There is another thing that we should consider, but it's at higher frequency. So the wireless link for the internet is at 5 gigahertz. There's a 5 gigahertz link from Forth to Skinakas. I think it's at a quite high frequency, but maybe we should consider even shutting down this system too.
Yes, and I'm undecided because will it be shut down forever when Argos will be installed there?
That's a good question.
Yes,
Probably not.
because there
I
will
mean, we
be.
want the. I would be more comfortable, creating a realistic, even if it's not, completely clean from. I would be more comfortable, creating a more realistic environment.
Yes,
Like
but
maybe don't shut down everything completely. Don't shut down the observatory, because this is not what will happen when the instrument will be operating.
Yeah.
Right, there will be people going up all the time. There will be people, making phone calls. Maybe there will be internet links. So all these things, maybe maybe if not for the entire campaign, but maybe we want to leave some of these things on to just see what is the that would be my.
We could try shutting down everything and having just, let's say, a few measurements with the cell phones on and the rest of the things on, and just do a slight comparison to see what will happen.
Yeah,
when
that's why
everything goes on.
I think some
But
of
not
these
for the
things we
whole
can do.
time.
Yes, that would be my recommendation. I think some of these tests we can do before you guys come. So if we go there with an analyzer, then we can get an idea of what transmits what and what needs to be completely shut down. Things like that.
Yeah, but if we go now with another spectrum analyzer and completely different methodology, the comparison will not be one-to-one.
No, we don't want to make
Just to get an idea. Just to get an
Yeah,
idea.
just to
okay,
get an
okay.
idea of if there's something leaking or if there's
Okay.
something that we didn't
We
think
haven't
about.
thought of it. Okay, yes.
Because there's another thing, looking at the data, and another thing, thinking, oh, there must be this and this and this and this, because
So the mobile phones are operational up there?
mobile phones, yes.
So it's covered. The top is covered.
It is, yeah.
By whom?
It has very good line of sight, as told you. I can see many.
Yeah. So from the
They
so
say
from the
look
it's
down, don't look up.
Look
yeah. So
from
it's
the view.
it's the highest peak in the mountain. So you can basically see most of Heraklion. You can see.
But the base stations look down. They do not look up. I mean, have you tried to call with your mobile phone? And it
Yes.
works.
Perfectly.
Oh,
So some of them look up, apparently.
interesting.
And the other thing, Thanasi, now that I remember that you mentioned, is about the, also making some measurements of the sky to get some idea about the satellites.
Yeah.
Would it make sense to try to time these measurements for when there are things passing over? I mean, we can try to get the orbital elements of the all the Starlinks and stuff like that, and see when there's something.
You mean time stamping the measurements?
No.
Yeah, I mean, we can do this post processing. I mean, we can get the orbital elements. They're all publicly available, and see what was where when we're taking the measurements. But if we're going to spend only a limited amount of time looking up, then we can probably time this measurement so that at least for some of the time we get signals that there are satellites passing over.
Can you provide this info, Yanni?
Yes, it's
Okay.
quite easy to
so
get.
For the week from 3 to 8 July, 8th of July, just to know that these times we'll have some Starlink satellites passing above Skinakas or above Crete, or
Yeah. No, that is easy to do. Yeah.
Okay.
So, is your equipment capable of time stamping the measurements?
We'll have the clock of the laptop, so we will have the time on the file.
Okay, a rough
Yeah,
estimation of the file shape. Okay,
that's more than enough, I think.
Can be several passages of satellites of the day, actually many.
Yanni, if we can have it at least 1 week before we come to create, in order to schedule the measurements. I mean, I have to schedule step by step all the measurements, so I want to know that at least 1 week ahead, if that's possible.
Yeah, sure.
Thank you. So we'll arrive on Monday morning, 6:30. We'll come to your home and we'll ring your.
I'm already awake
Both.
at the time. No, I will probably come pick you up, guys. But you will rent a car at.
No, we'll bring
enough.
our car. We'll bring one car.
Okay.
But we will come to Forth with the car and one taxi or something. We'll check the equipment and we'll measure one session at Forth, and we'll sleep at Lato Boutique Hotel, and then early in the morning we'll come to Forth. And as you told me the previous time, you said that you will take the equipment and will take the equipment up to Skinakas. Yanni, is that correct, or I misunderstood?
Yes, I think Nikos and Stefanos know the details, but I don't know who is allowed to, transfer the this RedCom. Nikos. So Nikos will take it up to them.
Yes, but I will. I mean, regarding the spectrum analyzers and things like that. I don't know if you, Thanas, if you have a car, correct? You will rent a car, correct?
We'll have our car, yeah.
Yeah. Oh, I mean that I will not suggest put spectrum analyzer, expensive spectrum analyzer in a trailer. So no, perhaps with car, it's better, yes, to avoid any potential, but we have a good. I mean that we may transfer it, but a rack. But okay. I would like to show you something. If you allow me to take a look, what can I share my screen? Yannick?
Yeah. Go ahead.
I have found some pictures from the when I went there. Can you see my screen? Is it okay?
Yep.
So here is from the observatory. Some pictures. So you can see here is the city of Heraklion. Correct? Please correct me. And this is Dia. It's an island in front of the. So here is Heraklion. Yanni, tell me, and I think that, let's see if I have all the pictures here. But I think that here is the...
Yes, it is Heraklion, it's northeast.
Yes, it's the correct. I mean, these are the places, the houses. As you can see, when I went here, I saw a lot of signals that this is because there was line of sight from this area. And okay, some other, okay, see, here is inside the telescope, but I would like to show you, this is the one that the Wi-Fi that we have installed there for the transmitting to, okay, this is me. And okay, here is observatory. So this the all, yes. And just here is the, so here is the road, and here is Heraklion. You can see there is a lot of, line of sight.
Mm-hmm.
And okay, so here is here is the place for visitors and also the people that are staying. And here, correct, please. The batteries are before, are in the other room, Anna?
No, the batteries you didn't show.
It's somewhere here.
You're now looking. No, it's not in the picture. It's behind you. It's behind the photographer.
Yeah. So okay.
You are looking to the east.
Here. Here's
No, in the small
No.
stone house, it's the
Yeah, that
generators
one.
inside. No,
this one,
the batteries are towards the west. So
somewhere
even
here. Hmm.
you cannot show in the picture. Now the picture
Yeah,
looks
just
split.
at the orientation. And here is the plateau that we're
I
considering.
cannot see your
Yannis.
mouse, so I don't know where you point.
Yeah, sorry. Yannis, here is the plateau or not? This, I don't know. If it is the place that we're considering that will be the place for the location. Somewhere here.
It's part of that, yes.
Yeah, as you can, it's not so, you know.
No, now it's not accessible by car, so.
Yeah. So just considering
we'll
some
try
other
to-
constraints on this. Okay, just to have an idea what is Skinakas and what is the place, and something else that I would like to show you. Just give me a second about the trailer. That okay, perhaps you didn't have the chance since I have in front of me. Give me a second to. About the trailer, what's the trailer? Okay, it's an old presentation, but perhaps you can have a look what is there. Okay, it's from an old presentation. So okay, it's the mobile, which you can see here. Yeah, so this is the trailer, at least the first version, because now it's better, different, you know. So you can see here, and okay. I don't plan this how it was designed, but more or less what is, I don't know how it was built, but you can see.
You showed in a previous photo, we have a pickup car at Skinakas, if it's of some use of you.
No, it's my car anyway, that I will have the license to travel. But see, here is the solar panels, how it's easily, and then you can see the antenna. And you can see now, I think that it must have just now this. So it's now it's you know more cables and more antennas, but we can leave them. But as you can see, you know, can go up to 5 meters, 9 meters. 9 meters. The mast is like this, dramatic, and also so inside here is the electric generator, and from the inverter and the batteries, and also there's a place for a rack for to place an EPC or you know other things.
Nico, you may stop at any intermediate height, so we can stop at 5 meters, huh? Is that correct?
Yes, but does it play any role? Why not going to?
It does, because we have 10-meter cables.
But I have, this is the one question that I would like to make you. What is the antenna? What it's an N-type SMA? What is your you know the
Connector.
The connector. SMA, eh? Okay, I think that we have cables around. We have a lot of cables around, so we can use it.
Because we will have also the LNA up there. We'll have also the power supply for the LNA up there. So it's not easy. So I want to be up to 5 meters, if that's, or 6 meters.
We can measure, we can stop it as we want, it's not a problem. We can also, if we want to have a standard standard way, what we've done in the exhibitions, that we put some things so to avoid to reach the, you know, the higher in the building, inside the building. So we can find the standard height that we can stop there. So don't worry. I mean, that will fit. Just the only problem is that perhaps every time you have to put the antenna or leave it or whatever. We'll find a way. That this is the reason why we'll have some initial experiments here, and also, you know, to in the fourth to finalize everything, to go there and be sure that you know, everything is. But as a second plan, we have also our cables that we'll use. This is my.
Can I ask? Have you measured the wind limit that this can stand up?
You look here. Look at.
We have high winds at Skinakas.
I know. It depends. If it is too windy, we'll go down. There's no need to to destroy
What
everything.
is too strong? 40 kilometers per hour, 50, 60,
There are some
70?
standards. Look, there are three different categories. The first one is without any foots. Okay, we have without I don't know how the foots of trailer, something like that. Just the wheel. And then the mast can go without any problem up to, I don't know, just tell 20 kilometers, just give an idea. The second one, don't take the numbers. The second one is put the foots of the trailer so it's more stable. Usually this is how we use it. And the third one is if it's too strong, there are some extra rings or something like that.
Okay, be prepared for the extra.
Yeah. Okay, I know. We have
Because,
done or played so
usually we have high winds at Skinagas.
we'll
not uncommon.
we'll try anyway. We have to, we have already this thing, so we'll do.
You know, Nico, there is another problem here. If we have a really strong wind, then the way the antenna is going to match the mast is a problem. I mean, when you say strong wind, what do you mean?
Me or Anna?
No, Anna.
Me, I guess. We can have 60 kilometers per hour that we can work, the observatory works. If we have over 80 kilometers per hour, the telescope doesn't work.
In July?
Yes.
Oh.
Yes, it's independent of the...
We'll
also
find the antenna in Anoia, I think.
In Egypt.
We have found a dome in the mountains. I don't know where you were. Slices of a dome, an old dome.
So we'll do. So we have to do some tests of the.
This is what I was asking. If you have tried your equipment with high wind.
Trailer weeks, and then we have to monitor the wind, so that if we have any suspicion that there will be very strong gusts, then we just stop.
The problem will not be the trailer or the mast, because we can secure both the trailer and the mast, but the problem will be what Thanas said, the antenna. It has a very nice shape that it will act like a sail, and if the wind is too strong, it may rip it off from the trailer. So try to make it as robust as possible, the build for the mounting on the mast, and let's hope that we won't have a strong wind during the campaign.
The other problem, Stephanie, is that we have to rotate the antenna. So
yeah,
if we have a strong wind, 60 miles per hour or 60 kilometers per hour, then it will be really hard to rotate also.
Let's say that an average will be 40 kilometers per hour.
40.
A medium, like a normal.
But not always has strong winds. So let's go.
Not always.
Let's see the weather, and if we can see the weather, and if we think that on Wednesday perhaps will be more gusty day, or we can go on Monday. That's calmer. Okay, let's be kind of flexible in this way, if we considering the weather. But we can not do something now. But
no. Just wanted to tell you, because the weather conditions in the top of the mountain can be hard, like windy, or you can be inside the cloud. I don't know if I get it correct, that your measurements are just fitting the time period you will be here. I will put an extra time, because sometimes the weather can be bad, not to be just the necessary time to take the measurements, because maybe one day the wind is very high or something with the weather is not going well.
May I suggest something? Is it possible to build a small dome made out of plastic, or to buy a small dome made of plastic to cover the antenna on the top of the mast?
But it's covered. I mean, it's covered.
No,
No, like
if
a
we put a
spherical one.
dome, a spherical dome, it will have less resistance and it will not be affected.
How will you
How big is the antenna? How big is the antenna, Thanasi?
It's
How
like
big?
the ones that we have, the blue ones.
Okay, so we have a box there. We can put it in the box that's already plastic, no problem. We have already installed the box there.
But it's
something
not
like
only the
this.
antenna, Nico. It's not only the antenna. We will need also to put the mechanism that rotates the antenna.
yeah, we have a special mechanism to rotate the antenna. And also we'll have the LNA above and all this stuff. I mean, close to the antenna. And
But if you think that we can find the bolts, plastic bolts that we can fit there, the equipment without problem to rotate it, okay, we may consider this. I mean that if you think, and we can leave it the night without need to put it away. But second thought, so keep in mind, if there is a box that can fit this, this could be okay, a possible solution.
okay, we'll check it.
Yeah, if possible. I mean, that's just because
Yeah.
will not play any role for the measurements. I mean, the plastic.
Nico, I saw that in your photo, your antenna did not have a radome. So maybe it is a bit better from a wind point of view, because our antenna is a hyperlog antenna, you know, from Aronia, the classic ones, with a plastic radome like a shark fin, let's say, okay? And this definitely has some, you know.
It's a bicolog, you mean? It's a bicolog model?
Hyperlog, printed hyperlog.
Hyperlog. This one model, this model. Okay,
Yeah.
it's the classic
I
one.
saw
Okay.
in the photo that you had something like a wire, but without a radome. So maybe
We have also these hyperlogs antennas. I mean that is, and anyway.
maybe an antenna like this has a better behavior with the wind, let's say.
Yes, but the problem is I think the rotator. This is the most, you know, the functionality, the nice functionality. Yes, but let's see how we can. But
and it's
okay.
heavier. It's heavier. Let's say that it matches what you would like to have. It's quite heavier compared to the Aronia one. Aronia one probably has a PCB design inside.
Yeah, it is.
Yeah.
So let me ask Anna. Anna, what time can we be up there? I mean, we can go up at 8 o'clock and start measurements at 8 o'clock, 8:30, and stop at?
The technical personnel of Kinakas is from the morning. We have to do something, and there is usually the observer with an assistant observer in the night.
So it's 24 hours, you mean?
Yes.
So if the weather is good, there's always someone up in the mountain.
Yes, for
Thanasi.
observation.
So we can.
Okay.
Because
if it's 100% forecast that it's going to be cloudy, then yes, the observer will not come. But the technical personnel will go up to help you, of course.
Yeah. At any case, Thanasi, at any case that if everything goes wrong, okay, you are close to Athens. I mean, we can arrange. If we standardize all the procedure, the equipment, and if there's something that, you know, so let's not think that everything go back, bad. Let's consider that everything will go fine. Otherwise, okay, you may have the need for a second visit. I mean, don't have all the risks in front of us now. So, okay, I'm pretty sure that
I know there is a lot of budget in fourth, so we don't have any problem with that.
Yeah, for sure, Gianni. They said to Gianni is the bill.
So we can probably, yeah, if the weather is very bad, then we can probably just take you know, one cycle of these measurements at Nida, which is where we actually want to put the, you know, this is the plateau near Anoia where we actually consider for the full array, so the full telescope.
Yanni will not have the time. If we want to take a full measurement, 5 sessions in Skinakas.
Yeah, but I'm saying if there are thunderstorms in Skinakas.
We'll go to a restaurant. There are some nice restaurants.
Oh.
Stay inside. So
Go to
the safer
Anoia
choice.
So we'll stay in
There is-
Anoia. Yannis, we have booked a hotel in Anoia, as you said, for 4 nights.
Yeah.
Tuesday.
Yanni, for us
Friday.
as well or not?
Yeah, I will. I was actually. Yeah, I will book a room for me and
Very,
probably
very
the
good.
kids as well.
It's just, I mean, that, okay.
Because I understood that you need 6 full days to make a complete set. This is correct? I understood well?
5.5.
What?
5.5 days.
Yes, that's why I brought up the thing about the weather, because I think you should leave at least 2 days for some bad weather happening, like
In
too
that
high
case,
winds. It may
okay.
not, but
Yeah,
just not to be only just enough the time.
Yeah. So yeah, I think that might already be budgeted in because the 5.5 days is 5.5 work days, right? It's not 5.5 times 24 hours. So there is some, there is some flexibility already there, but let's see.
Okay, good.
So fingers crossed.
I will consider to don't include Saturday for this. I mean that perhaps Saturday, but it's not a working day Saturday. I mean,
For us, it's a working day.
is it in Athens? Piraeus?
No, it's not in Athens, it's in Crete.
No.
It's in Crete, so it's a working day.
In July, usually Saturday is a weekend.
Okay, so we're like 5 minutes past the hour, so let's stop here. And thank you very much, everyone. And Thanasi, thanks a lot for this nice presentation, and really look forward to this.
Yep. Yanni, we have also to discuss sometime the issue with the cost of the antennas and the dishes and all the stuff.
Yes. So
So the next meeting is?
So the next management meeting is next week, I think. So we can discuss it next week.
A holiday. It's a Greek holiday then.
No. So the week after the Greek holiday, yeah. But the thing is that so Stefanos has we're trying to meet with local people again this week. So we'll have some updates from them as well. And then once we have all the information available, we can discuss about how to proceed with.
Let me tell you that the news for the building of the horn antenna are not good news, bad news. I mean about the cost. The cost is really high. So we're not sure. I don't want to tell you a price now, but it's really disappointing.
All the alternatives.
All the alternatives that we have up to now. We are waiting for some more, so I will not tell you prices right now, but I'm afraid that the horn will be too big, so the price will be high. Okay, we will discuss it.
Okay, yeah, let's discuss it once we have more information about the antennas as well.
Good.
Okay, thanks everyone, and we'll keep in touch, and I'll see you in a month from now.
Okay.
Thank you.
Γεια σας.
Γεια σας.
Γεια σας.
Bye.
Bye.
Bye.